Today is November 18th, 2022. This is my 139th episode for C++ 17 2023 CUDA SQL OpenCell DBB Balkan. This is also 5th episode for Advanced Recursion, Parallel Numerical Derivatives, Parallel Numerical Integration. We will learn how to retrieve type information, also how to use consteval, how to create sequence, also the type sequence, how to use CPG literals. These are must-watch videos. If you click this link, you can learn how to create or use create sequence, how to use constellation. Also, this is my 5th episode for Advanced Recursion and Parallel Numerical Derivatives. So, if you haven't watched my previous videos listed here, you may have to watch them. Please double-click this link. From our previous episode, episode 138, click Show More. Download current video's source code. Click this link. Show in folder. Unzip it. Rename 139. Copy the folder. Paste it in your working directory. Open up Visual Studio Code. CPP 17 2023 Parallel. Select folder 139. Click this button. 6 sequence.cpp. Hit enter. Ctrl B. I copy and paste these links. Here include CPG, STD extensions. Include CPG, array, tuple, vector operations. Namespace, CPT, CPG, types. Void test, advanced, tuple operations. Int main, copy, paste. Now here auto A, std, tuple 1, 2, 3, 4, 5. Copy, paste. This is B. I will modify it to 2.5. Then 3.3 F. Then long, unsigned long. Auto C, A plus B, std, cout, A plus B equals C, CPG, and there. I will use uppercase and there. std, cout, A, type. I will use 2 angle brackets pointing to right hand side. Please note that in this case we used 2 angle brackets pointing to left hand side. In this case we use 2 angle brackets pointing to right hand side. Here A, CPG, and there. Copy, paste, this is B, 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 and L. This is C, 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 and L. Now we are testing this program. You can use any compiler. CD 139 Advanced Recursion, DB, CPP, EHSC, SDD, C++ training. 6. Sequence.cpp or D.exe. We can use fno SQL. Hit enter. So this is the command string. Copy, paste it here. We display D. Now let's check. So A plus B. This is A, this is B. The result is C. The value of A is displayed. The type of A, int. This is int. Double. This is double. Int. Int. So unsigned long. Unsigned long. The value of B, type int. Int float. So this is float. Long. This is long. Int again. Okay, let's see the type of C. We added 1 plus 1, 2. 2.5 plus 2, 4.5. So we haven't lost precision of addition A and B. So double int 2.5, 2.5 double 2 int. The resultant type is double. Int float. Int float. The resultant type is float. In this computation, we haven't lost original arguments A and B's precision in our result. Now we can try like this. Over auto D, for example, 3.5 float. Then we can put D. Now we fix like this. Then this should be D. Now we build again. CLSD. Now float, double float, float, float. Because we divided with a float. In this case, double int. So this is type double. Double. In this case, its type is float. In this case, 2.5 plus 2. In this case, its type is double. We never lost precision in our computation. Right-click this operator, go to declaration. So this is the operator defined in CPG tuple operations. In this code, you can find I used for workhorse. Also, I used for stallion. Basically, all these operations are defined using for workhorse and for stallion. I am not sure if such operation is any useful, but I created this operation to test for workhorse and for stallion. For example, order sn minus 2 signed integer, order un 1 unsigned long unsigned integer. Now order misfortune sn plus un incorrect operation std cout misfortune std enter. We build again D. Obviously this is garbage. Okay, negative 2 positive 1, the result should be negative 1, but this is garbage value. But let's try it. This is negative 2 unsigned long. I will set it 1.0. If we rebuild CLSD, note the result, the value of C, A plus B divided by D. This is 1.0. The value of C is minus 1. Minus 2 plus 1 minus 2. This operator works perfectly. It even handles signed, unsigned operation. Right click, go to definition. Please understand, it uses CPT SBO. So we can fix this problem. Like this, correct. CPT SBO. We can fix our problem like this. Okay, let's try it. CLSD. Now the problem is fixed. Negative 2, positive 1. This is signed integer. This is unsigned integer. Our operation works correctly. If I use this, then it does not work. CLSD. It does not work. I will address such issue in some future sessions. Now, here, void test, reverse tuple. Copy this function, paste it here, auto t std tuple 1, 2, 3, 4, 5. consteval auto n std tuple size v. We have to pass declare type t, the type of tuple, then minus 1 consteval then auto task. We capture T, this tuple, then auto I. CPT sequence I SEQ. We created a lambda. In this lambda, we return SED tuple. So we create a tuple SED get I T. Then we have to expand because I is parameter pack. Okay, I is parameter pack. Now here auto R CPT for stallion. We pass n is defined here. Then -1. We pass task here, semicolon, SED, cout, T type. We use this right pointing angle bracket. Then T CPG and copy paste R I will use uppercase and L. Now here 5F. This is 4.4 double. Now we build this program. We rebuild CLSD. Note that 1, 2.5, 3, 4.4, 5. This is reversed. 5, 4.4, 4.4, 3, 3, 2.5, 2.5, 1, 1. The type is also reversed. Int, double, int, float, int. To reverse the tuple T, we used for stallion. We can print out SED, cout, N, CPG, and there. Or here, SED, cout, SEQ, type. We use SEQ. Sorry, this should be CPT, CPG, and with this CLSD. So n is 4. In this case, n is 4. So we are visiting 4, 3, 2, 1, 0 in reverse index using posterion n is 4. This 4, then -1. This -1 is not included. So 4, 3, 2, 1, 0. -1 is not included. We visit each element of tuple T in reverse order and generate tuple. So this is the result. Posterion is super powerful. Please notice that CPT posterion uses n and -1 to generate CPT sequence. That is, posterion calls task this lambda and passes CPT sequence to this function. Simply put, posterion is sequence generator. Void test sequence or seq1 CPT create sequence. We pass 10. This is function std cout seq1 equals seq1. We want to check out its type like this. I again use right pointing angle brackets, then seq1 cpg and there. Now copy this function, paste it here, disable it. We will rebuild CLSD. Okay, we used create sequence by passing 10. seq1 is displayed here. Int 0, 1, 2, 3 up to 9. 10 is not included in this list. Int means that the type of 0, 1, 2, 3 are integer type. Also, the type of seq1 is std integer sequence, int 0 up to 9. Now, auto seq2 cpt create sequence. For example, 5 unsigned long. We generated sequence 2, then sequence 2, 2, 2, and there. We build again CLSD because we used 5 unsigned long, 0 up to 4. In this case, 5 is not included in this sequence. Now, auto seq3 cpt create sequence. Now we pass 9 -1 copy paste sequence 3 sequence 3. We build again CLSD. So we passed 9 -1. So 9, 8, 7 up to 0. -1 is not included. This is decreasing. Now copy paste. Here we can use 0, 10, 2. This is sequence 3, 4, 4, 4, 4. We build again. CLSD. Now see, it starts with 0 up to 8. 10 is not included. It steps by 2. 0, 2, 4, 6, 8. Now, if we want to add numbers, for example, it starts with 1. Then this is 5, 5, 5, 5. We build CLSD. Now we generate starting with 1, 1, 3, 5, 7, 9. The step is 2. Now we can try in reverse. 6. We start with 10, negative 1. Steps should be negative 2. This is 6. 6. 6. Here we rebuild CLSD. Now 10, 10, 8, 6, 4, 2, 0. We step down with negative 2. In this program, we start with 4. If you disable it, then enable it. CLS rebuild CLSD. Now scroll up. In this function, n is 4, so this is 4. This is step 4, 3, 2, 1, 0. It is reversed. Using this reversed sequence, I represent these numbers. Sequence, 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 sequence. I represent these numbers. We use signed long. As you can see, the type of sequence is integer sequence. Type long. These numbers are type long because we use negative number 1 to decrement. Posterior is simply sequence generator. CPT sequence. This I represent these numbers. I would highly recommend you to watch my previous videos. Now you will better understand how I used posterior in my previous video.